It's Mrs. Woodruff. Today we're going to continue our discussion of simplifying expressions with the rational exponents. You're going to find it's not really that different today. We're just going to put some variables in there. So here we have an x raised to the 2/3. So just like we already discussed, the denominator will become your index in the root, and the numerator will become your exponent of the variable underneath the radical sign. We've already talked about how there's two different ways to think about this, as we could take the exponent first and then the third root, or we could take the third root and then raise the whole thing up to the second power. These are equivalent expressions. However, this one right here, when you're evaluating and substituting numbers in, is often the better choice because you make something smaller before you make it larger. So if we take a look down at this next line, we have x to the 9th, and we're going to take the third root of that. If I change it over to its radical exponent, the 9 becomes the numerator, the index of 3 becomes the denominator, and we see that 9 divided by 3 is a 3, and we have x to the third. This time we're going to take a look at it from the perspective of the rational exponent rather than the root. And we'll see that this whole group is being raised to the 1/4 power. That happens to be the fourth root of 81. And then we're going to take that x to the 8th and raise it to the 1/4. And when we raise a power to a power, we would multiply and get 8 over 4, which is going to become an exponent of 2. And as we raise the 16th to the 1/4, we would get 16 divided by 4, which would be the 4th. Now this guy right here can be simplified further. We're taking an even root of a positive number, so we will get two answers, two solutions, two roots, and the fourth root of 81 would be plus or minus 3, and our final answer would be plus or minus 3 x squared y to the 4th. Down here we're going to take the third root of an expression that has a variable in it. The third root of 27 is going to simply give us 3 because it is an odd root of a positive number. So there's one solution, one answer. Now, if we take that 12 and divide it by the 3, you'll see we'll get the 3a to the 4th. Now let's take a look at some other examples. So here we have a root. So we're going to take the third root of this whole group. So there's kind of a way we can look at this by thinking that 125 is 5 to the third power. That's another way to kind of think about it. And then y to the 6 could be y to the second to the third power. So we could kind of look at that way. And this kind of explains from the root perspective what's going on. The third root and raising something to the third cancel each other out, which would leave a 5. And again, the third root raising to the third power would cancel out, and you end up with this answer. Now, to be honest, the way I look at it quite quickly is to say the third root of 125 is 5, and if we take that 6 divided by the 3, we get the second power. Okay, again, from the rational exponent view, everybody in the group is going to get the 1/2, which happens to be a square root. So we're going to have 9 to the 1/2, u squared to the 1/2, and v to the 10th to the 1/2. So first, we're going to start off with that 9 to the 1/2. There's the u to the squared to the 1/2, and then 10 to the 1/2. The square root of 9 would be an even root of a positive number, so we're expecting two answers, plus or minus the square root of 3. We'll get u to the first and v to the 10th. Last example here on this page is to take the fourth root of this quotient. And remember, we talked about the fact that we can cut that root so that the numerator gets it and the denominator. You can do that across a quotient or a product, not an addition, not a subtraction. So the first thing I'm going to do is kind of cut that root. Now remember that 8 is 2 to the 4th, and that's explaining why we can kind of cancel those out. Oh, by the way, 8 divided by 4 is going to give me the 2. And up here, the fourth root of x to the 4th is going to give me good old x. What I'm going to suggest at this point is that you pause the video and just try these 4 examples on your own, and then we'll come back together and see how you did. Okay, everybody, let's see how we did. So x to the 6 to the 2/3, when we raise a power to a power, we multiply. So I'm seeing 12 divided by 3, and boom, there's x to the 4th. This whole group is going to get the 1/2, so we're going to have 16 to the 1/2, x to the 4th to the 1/2, so that's the square root of 16, and then 4 divided by 2 would be x squared. In the denominator, nothing's happening. Square root of 16, again, is an even root of a positive, and that's why we're seeing that plus or minus 4. And the x squared, of course, came from the 4 divided by 2. Now, before we stop here, 4 divided by 2 can be simplified, as well as, look here, we've got 2 positive exponents in a quotient. Where are there more? On the bottom. How many more? 1. So we're going to end up with 2 plus or minus 2, and there will be an x to the 1st on the bottom. And of course, we make that the invisible 1. Okay, the 4th root of 81, I'm expecting 2 answers there because it's an even root of a positive. And then the 6 divided by the 4, the 8 divided by the 4. That's kind of the quick way to look at how to simplify that radical. So the 4th root of 81 is plus or minus 3. 6 divided by 4 is going to leave us with a rational exponent of 3/2, and 8 divided by 4 is going to give us y squared, and that's as good as it gets on that one. So here again, I'm going to take the cubed root of the 8, the cubed root of the x to the 6th, the cubed root to the y to the 12th, and I'm going to cut that, and I'm going to take the cubed root of the 27. Cubed root is only going to give me one answer because it is an odd root of a positive. So we're going to have cubed root of 8 is 2. 6 divided by 3 will give the x an exponent of 2. 12 divided by 3 will give the y an exponent of 4. And don't forget to take the cubed root of the denominator. And there's our simplified answer. That's pretty much all we need to know with variables at this level, but I'm sure somebody out there might be questioning this. What happens if the variable's exponent is not a multiple of the index? So for example, x to the 10th, 10 divided by 3. There is sort of a way we can partially simplify this, I guess. But if I take that x to the 10th and make it the product where this variable is a multiple of that, I can sort of do a little bit of simplifying. So that cubed root of x to the 9th would simplify 9 divided by 3 to x to the 3rd. But this guy would get stuck under that 3rd root. So we'd have x to the 3rd kind of on the outside, and that x to the 1st gets stuck under the cubed root. Basically, some of the factors of the x will get stuck under the radical. You absolutely do not need to know this at this point, but I know somebody was probably thinking, what if? So that's how we work with variables as we're simplifying our rational exponents. I will be posting a worksheet for you to try. Have a great day, everybody.